My name's Karen George. I'm the Vice President of Advancement at Spalding University, and it's my absolute pleasure to welcome all of you to campus today. I'm welcoming you on behalf of our president, Dr. Ann Kenworthy. She was unable to be here today, really wishes she could be here, but she had another commitment and cannot split herself into two. And if you're wondering, why are we on Spalding's campus for a University of Louisville lecture, a University of Louisville event? Spalding recently joined over 25 proud partners of the Greenprint initiative. And this is a 10-year, yes, there we go. This is a 10-year collaborative project, and it's designed to produce a greener, healthier downtown Louisville. And so today's lecture is all about improving Louisville's climate story. So we ordered a hot one for you. The high temperature is going to be 90 degrees. We just wanted to set the stage. Enjoy your time on Spalding's campus. Enjoy the pastries. Enjoy the lecture. And right now it's my pleasure to welcome Dr. Aruni Bhatnagar to the stage. He is the director of the Christina Lee Brown Envirome Institute at the University of Louisville. Welcome, Dr. Bhatnagar.
Thank you for the introduction. Thank you, everybody, for being here. You know, I know that you didn't come here to listen to me, but I thought that just to set the stage, have a frame so that we know what we're doing here with the University of Louisville's intents are able to sort of give you a sort of a brief overview of what we do at the Envirome and how this initiative fits into our overall worldview and what we are about in our mission. So this is where we are at the university and the campus. This is one part of our lab space. There are others that are also on the other side of the university. This is where we do the rest of the work. So we are spread over a couple of buildings and do different types of work. So one of the big strengths of the Institute is that we can do both fundamental work that actually probes basic mechanisms of how the heart works or the blood vessels work, but also to be able to use that knowledge to do translational work in populations, in clinical trials, in humans populations, community-based research, all dedicated to a single idea that we need to understand how the environment affects our health. We know a lot about genetics, and a lot of my colleagues have spent so much time, effort, and resources in trying to decode the human genome. But that's only part of the story, because with the genome, we also need to understand what the envirome is. So it is sort of a parallel to the genome, which has been understudied because it is a much more complex entity. It does not a set of codes, but a very sort of fluid, complex set of circumstances that we need to understand. But regardless, the envirome, in case you were wondering, is a complete set of conditions that surround us, and these conditions that affect our fitness, our health, and well-being. So how do we understand the environment? And this is in the terms of an envirome. And this, I think, for us is a major shift, because in the medical profession, we've been sort of thinking of disease as something goes biologically wrong with people. The plumbing stops working, the electrical circuits short circuit, but that's just one part of the story, and usually the end result. The origin of disease and health is in the environment, and that's what our commitment is, to be able to uncover these roots of human wellness and human disease. But it's not a simple task, because humans, we live in very complex environments, and these environments are fashioned by our social networks, by our circumstances, culture, and history, certainly things that scientists are not very comfortable in understanding or in talking about. But in order to get a real understanding of the envirome, we need to understand both, not only our biology, but also our sociology, our culture, and the things that surround us. So we think of the environment in different sort of layers. In the outermost, most primordial layer is the natural environment which exists within us, and they're outside us. And then this natural environment forms the stage or the canvas from which we curate and create social environments. And within the social environments, we create our own little personal environments by own choices or by own circumstances. So we have to unravel all of these layers of the envirome to understand what the impact may be and how it shapes human well-being and health. So we think that most of disease starts from living in conducive environments and dyssynchrony with the environment and the mismatch between the environment and the gene. And so in that sense, we need to look outside and step out from our laboratories and go into the real world and to be able to then uncover or discover the origins not only of human disease, but also of human health. At the Institute, we had a large group of people. We are over 30 members, and we have been prolific trying to understand different aspects of the environment. We have been very productive, at least certainly very visible, and not only within the academic community, which we interact all the time, but also our community, because we need to do things that matter in people's lives. One of the things that we have been criticized, especially in the past few years, is that science means just being in the ivory tower, that we need to have relevance to real world, that we have to do things in the real world. And this is what you'll hear today is our attempt, or one part of the attempt, to understand the real world and how it impacts the lives of the people who are here and of our community. We have a center to study the basic sciences. We have a center to study Superfund's chemicals that are very, very close to us. We have some very large Superfund sites next to us, and we've been funded by the NIH to study that. We study the different components of the environment, and we will talk about that a little later. And we also study how the city should or could work in a different way, and we understand what the problems of the city are in our urban design studio. And this is, I'm just going to show the last slide to brag about what we are going to be doing. This is our new, potentially our new home. It is on 4th Street. I welcome all of you to go there and see that we are trying to create not only an environment that we can work with, but also an environment that is healthy within our own lab. So that is going to be there soon, and I'm sure it will be a landmark in Louisville. So our overall goal is to create healthy cities, because we think that we cannot be healthy individuals without being in healthy environment. So how do we create healthy cities? By being able to understand what contributes to health in a city, and today is one of those initiatives in our attempt to understand what are the key determinants of health and disease in our city. So I will stop here and invite my colleague Ted Smith to tell you a little bit about one of the initiatives which forms the umbrella to this project.
All right, well, good morning and welcome. A big thank you to Spalding for hosting this wonderful gathering on a day that's going to be a little warmer than yesterday, which is appropriate. So I'm here to explain why you have a sticker right in front of you on the table. While Dr. Bhatnagar didn't get into all of the science that we do, trying to understand the sort of the fundamental connection between our health and nature, many of you are probably familiar with the Green Heart Project that we started 8 years ago in South Louisville. It's an ambitious, also expensive interventional clinical trial that's really trying to essentially prove what greenery is doing. And that project, we've spent a lot of time talking to a lot of cities about how they would want to have a Green Heart Project in their city. And it turns out it's proving to be a difficult project to replicate just because of its cost, complexity, and scale. And you know, at the same time, we're not making the progress we could make really embracing the things that we're learning in South Louisville right now. And so we tried to come up with a different way that cities all over the world could, I don't want to say be co-opted, but you know, to sort of embrace science as part of their development, redevelopment activities. And so that's really at the core of this Greenprint initiative. And it is to say, you know, it's not just going to be a bunch of academics trying to figure out how to run an experiment, you know, kind of all by themselves. We're going to do it together in community. We're going to work with everybody who's interested in understanding what this means for the future of cities and for the future of human health. And so this is, I'm dating myself, the collective impact model. For those of you that remember 55,000 degrees, I thought that was one of the most interesting and ambitious things our community had done when I moved here a long time ago, that, you know, we were just all going to work together. And we had different interests perhaps, but they were aligned on some goals. And so that would mean the public sector, the private sector, the nonprofits, everybody that was touching, in that case, higher education and educational attainment, could work together with a goal of getting more folks a college degree, right? And I think it's actually one of the superpowers of Louisville, Kentucky, that we have the ability, we're sort of the right size, we're just a few hops from everybody else, that we can get this kind of work done. And so the Greenprint initiative is we're gonna do the science, we're gonna keep moving forward, learning about how this stuff works, but we're gonna do it in an unusual way. We're gonna try to do it alongside of private development, of new parks coming on board, new opportunities with the tree canopy, try to layer the science in so that we can learn together what's working and how to really improve the health of our community and for future generations. And so that is the Greenprint project. It has all of these different kinds of partners, and like any kind of partnership, you know, there's hard days and there's good days, and we're working through it. But as you heard, Spalding, thank you, has joined the consortium. I think we're up to 30 members who have made a commitment to work together on this kind of learning and this kind of working. Here they are, and I would like, not to embarrass anybody, but to celebrate. If you are affiliated with any of these organizations, would you please stand so that we can say thank you? Anybody? Come on, it's good for the circulation. Thank you. We're all getting to know each other. That's the good stuff. I especially want to thank an organization who's made a lot of this possible, and that is the James Graham Brown Foundation, who has, back to 55,000 degrees, kind of understands that really making impact really does involve bringing everybody together. It's not one entity at a time getting resource, but it's really trying to figure out how to leverage that. And I'm particularly grateful to Mason and the team at James Graham Brown for being on this journey with us. And certainly the Owsley Brown Family Foundation has been with us for a long time, since we started the Institute, and has been a real facilitator of a lot of this, which I appreciate. Okay, this is what AI can do for you, or Casey, or whoever did it. I just want to make the point, because it's directly relevant to our next speaker. It's not just about what is the science that the University of Louisville is doing. It is how can we together learn? And you'll hear in a minute that this is not Dr. Stone's first visit to Louisville and first analysis of our city. It is the second, but it is the first time that we're taking all of that data and not just putting it in a report on a shelf, and no disrespect to the first round, but now we have tools. And so we have all the data from this current analysis that we're all going to learn about in a GIS hub. And for those of you who know what that means, you're welcome to join the hub. But to go and look at the data and play with the data. That's anybody from the nonprofit sector, anybody from the public sector, anybody from the private development community who wants to work with these data and really try to make a difference in our community. So this is our first commitment to shared data across the Greenprint Consortium. We will have other things coming online shortly that will help you see our city through a number of different lenses. So this is I like to think it's a highly leveraged and different than the Green Heart, where everybody can play in the sandbox and work with the information. And I hope that we'll all learn from each other as part of that. We're leveraging now $1 billion in development activities in downtown. It's not all hotels. There's a lot of things going on. And so that is exciting too, because we limited ourselves to just the nonprofit sector or the public sector. That number would be a lot smaller. And so we're very excited to work alongside the private sector, as long as they're willing to make some room, for some science and some modifications in their plans, all in service of really benefiting our community. It's not an impressive map, but this is kind of all the green spaces are in the Greenprint portfolio now. So we are really focused on downtown. We think that this is part of a strategy for the city for revitalization. We think nature draws people in, whether they're visitors, whether they're workers, whether they're residents. This is something that other cities around the world have shown, and some of the places that you all might like to vacation and go to are those kinds of places. So it's not a crazy idea, and it really could be part of a strategy to really grow a vibrant downtown. And then I'll sort of finish on the organizing principle, because sometimes there can be some confusion about what everybody does. Our real focus is at that intersection of where the environment is creating challenges / opportunities, where there are people. It's really important to us. We're in the School of Medicine. We work with people. And so to have the most effect, we want to know where the people are. They could be residents, they could be visitors. And then where can we do something about it, which can be a very tricky challenge. But at that intersection is a great opportunity, for our city. So I would encourage you to all to sort of embrace that. We have a focused plan for how to get this work done. And I couldn't be more proud to introduce the person you actually came to listen to today, Dr. Brian Stone, who, I have a very long bio that I'm not going to read all of, but he comes to us today from the School of City and Regional Planning at the Georgia Institute of Technology, where he teaches urban and environmental planning and directs the Urban Climate Lab. I'm going to let him give you all the rest of the story. So we've taken up too much of your time. So thank you. Welcome, Dr. Stone.
Okay, good morning, everybody. Thanks for coming early to hear a talk about what we've been up to in your city. And we've been up to a lot. So this is, as Ted mentioned, I've been here before, been here many times before. I'm quite fond of your city. And it's been really important to the work that we do in the Urban Climate Lab. And so I'll talk a little bit about that journey and why this has been important along the way. So I'm going to talk about these three topics: climate risks and assets in Louisville. And every city has climate risks for sure, and every city has some unique assets. And I think there are some pretty profound assets that you have here. So we'll highlight that. Give you an overview of what we have found with we call it our urban heat risk assessment. And so we've done that now twice in Louisville. We've got 2 points in time, and that also entails kind of a check-in on your canopy and how your tree canopies change over time. We really assess how the physical surface of the city has changed over time. So it's not just tree canopy, it's your parking lots and your streets and your buildings. And so we can see physically how that's changing and get a sense of how that's driving heat and health outcomes. And then finally, adaptation is a mode of urbanism. And I really want to conclude with this idea that we don't need to simply focus on climate adaptation as a standalone goal. I think if we do that, we will fail. Climate adaptation has to be in service of other goals, objectives that you have as a city. And so I think that's a very compatible set of goals and really easy to connect those dots. So first, the unpleasant news that everybody knows. This is one way to look at how the planet is warming. And these are known as temperature anomalies. You may have seen this, you've probably seen this, and it wasn't really well described. And so for those who don't really understand how anomalies work, I just want to take 1 minute here and explain what this is showing, because it's really important to what's happening in Louisville. And it shows you basically the scope of the challenge and then what the tools we have specifically in Louisville to address this challenge. And so if we think about the average temperature of planet Earth, we can measure that with weather stations that are now all over the planet. We can measure it with satellites. And if we measure it every day in every location, we can average the temperature for planet Earth over the course of a year. And that temperature is not what you see here. And so most people don't know what the average temperature of the Earth is. It varies. It's varied over time from maybe 56 degrees Fahrenheit to 60 degrees Fahrenheit. In all locations, if we average over all locations where we're measuring over the full Earth, over the year, about 60 degrees Fahrenheit. So that's a nice, pleasant temperature. The challenge for us is how is that changing over time? And so we know it's changing rather rapidly in recent years. And so temperature anomalies just say, what is the baseline temperature? Let's take a set of years. In this case, we're looking at 30 years from 1881 to 1910. What was that average temperature? Was it 60 degrees every year? Was it 56 degrees, 57 degrees? You take that average, and over that period of time, we get this zero line. So that's our baseline. And so what an anomaly is saying is, how is it changing every year relative to that baseline? And so this is, I was talking about Fahrenheit because we all know Fahrenheit. This is in Celsius because that's usually what it's in. And so what we're seeing here is that we are, of course, this is the baseline we set. and then we warm up a little bit, and we stabilize it, and then we really start warming rapidly up to the present. And so there are a couple of thresholds here that are really important to us. One is about 0.4 of a degree Celsius. This is the range we have been in for about 10,000 years. Either 0.4 of a degree above this 0 point, this average over 1881 to 1910, or maybe down to 0.4 of a degree below it. And so we have all kinds of proxy data, there's uncertainty here, but we have a pretty good sense that this is what the planet has looked like. This has been our comfort zone while we've been building our cities and societies since the last glacial period, so about 10,000 years. And so once we move out of that, we've been basically moving out of this my entire life, right? If you're around my age, 50, if you're in your 50s, we've been warming pretty rapidly and have exceeded this threshold for my entire life. And so this other threshold that you've probably heard of is 1.5 degrees Celsius, and that's the anomaly, the above the zero line, and that's where the global policy is now pegged. We do not want to exceed this threshold globally, because we know that's when we start to see high levels of risk in these natural ecological systems. We also know that we see risk in the urban systems, and so we also have different thresholds for that. So we're at a very kind of critical moment in that we have reached this threshold, and we might bounce around a little bit here year over year, but we are certainly going to surpass this 1.5 degrees. And so that has pretty significant implications for us and how we manage that. And so we want to think about what our tools are at the urban scale, specifically in Louisville, to respond to this, because the impacts are substantial. The most direct impacts are for our health. And so 1.5 degrees anomaly, global temperature, it's pretty abstract. It's pretty removed from us as individuals and our daily health. So what are the actual threats to us day by day, specifically in terms of heat? And so we've had some recent studies that have been looking at how does the human body respond to combinations of heat and humidity. And they do this in environmental chambers. So they take one of my I've got two children in college, one just graduated, and so these are our canaries in the coal mine. They volunteer for these studies, and so in this case, they have young, healthy, fit people do moderate exercise in an environmental chamber, and they raise the temperature and the humidity in the chamber to monitor how the core body temperature changes. And so these volunteers, the reason they get compensated, they swallow a capsule, and that capsule is reporting out instantaneously their core body temperature. Okay, and so for every second they know that core body temperature, and so you've got the light exercise, they're raising the temperature and the humidity, and what you see here is that core body temperature raises, and then it stabilizes here. That's thermal homeostasis. That's your body starting to sweat to cool yourself down. That's a natural process, it's critical. That sweat evaporates off our skin, and it kind of arrests that core body temperature rise. Once we get beyond this point where we start to see the increase again, then we're getting up to 37 degrees Celsius. That's that magic 98.6 that we all know, Fahrenheit. That's a fever. And so when we get to that point, we have reached a fever. And so what is the combination of heat and humidity just in the outdoor environment that would make all of us, after some amount of time, about an hour, start to move into a fever? It is a specific temperature that's pegged to what we call wet bulb temperature. It's not very familiar to us. It's sort of like the heat index. It's a combination of heat and humidity, but it's specifically pegged to how our physiology responds to that combination of heat and humidity. So the wet bulb temperature is 87 degrees Fahrenheit. Doesn't sound very high, but wet bulb temperature is a very different scale. And so at present, no U.S. city, at least in the temperature records we have where we've been measuring wet bulb temperature, no U.S. city has reached 87 degrees Fahrenheit, but we're getting close. And so when that happens, we will be dealing with a rather significant public health problem. We will likely need to, as we're monitoring this, cease outdoor activities. Are we going to shut down Louisville in the next 5 years because of a wet bulb temperature event? Probably not, but we're probably going to hit it. And so initially it'll be an hour or two. As we continue to warm, it'll be entire afternoons, entire days. That's going to be very disruptive to our lives and threatening in cities. And so we have to think about this in a very significant way in a compressed timetable how we're going to respond to this, because we're on the threshold of it. So you can see here, I'm advancing instead of laser pointing, sorry, that Louisville here is 84 degrees. No, yeah, 84 degrees. So 3 degrees from that threshold. We have, I think it's Jacksonville, 86 degrees. So this is just 1 hour of the year in the last about 20 years, the maximum wet bulb temperature. What we see in Louisville is consistent with a lot of these cities. We're about 3 degrees from it. But we also see in Louisville that Louisville has jumped 3 degrees in a single year. So this year, Louisville could cross 87. And so it's a very significant threshold for us to keep in mind and to think about how we're going to respond to moving forward. Okay, so we know Louisville's one of the more significant cities for heat and humidity risk, and you can see here on the map just where those major areas are. These are, largely river valley interiors that have a lot of humidity, and we know just walking in today, we're already having a humid morning, and so that's part of the landscape. So that's the risk. That's the current kind of climatic profile that we're confronting here. It's not that different than many cities, but there are assets, and so we have humid heat as a risk in Louisville. But generally, the latitude here is very favorable. And so as we think about where are residents in the U.S. likely to move over the next half century, it is going to be in what we consider this kind of Goldilocks zone here. And Louisville's right in the middle of it. And so, yes, you have extreme humid heat. Much of the year, it is quite a pleasant environment. And so relative to what's happening along the coastlines in the southeast, what's happening in the west, what's happening in areas that are subject to wildfire, the projections are there will be lots of interior migration, and a lot of that migration is coming to you. And so part of the question to pose today is, do you want the migration? I don't know if you want it. You probably won't have much choice. But I would think about starting to plan for that and maybe how to leverage that for this larger set of goals that you have for your city. So the first asset here, 4 assets, is latitude. I think this is a very favorable latitude to be where you are. Second is liquid water. I know this sounds like I'm talking about a mission to Mars, but really it's just about having easily accessible water in tremendous quantities. This is a very unique and valuable asset. There are western cities that typically have large volumes of water in their snowpack, and as we're seeing this year, that snowpack is just not a very reliable source of water. And so there wasn't a significant snowfall out west this year. That snowpack is greatly diminished, and so that's simply not true with the Ohio River. And so this is going to be, and has always been, a critical asset to your city, and I think that will continue in the future. The third asset I want to highlight is land. And so you have lots of available land in the downtown district where we are right now that can be leveraged for the purpose of adapting to these changes. And so this is often overlooked when we talk about climate change and adapting to climate change. It requires lots of land. And so we're going to need spaces that are designed to flood, that are floodable spaces, usually just parks that are designed to flood across your city. We're going to need lots and lots of more tree canopy, green spaces, but we also need more space for things like affordable housing. So we have lots of demands in this district, and while I know it's challenging to have surface parking converted to other uses, this is not an asset that many cities have. So Chicago has latitude, Chicago has water, it does not have a lot of land, particularly affordable land. And so this can prove to be a tremendous asset to you as you move forward to manage some of these challenges you're confronting. The last of these is leadership. And so, as we've mentioned, I've been here before, and I'll speak a little bit about my journey with Louisville and the kind of work we've been doing here. But I do, through the work that I perform with the Urban Climate Lab, we collaborate with a lot of cities. And so I travel and I meet with cities, and sometimes we're brought in by the mayor's office, sometimes we're brought in by university, sometimes we're brought in by a nonprofit focused on urban forestry or energy initiatives. And so you get to see how these institutions within cities collaborate. And you have a very strong set of institutions here that are collaborating, at least from my experience. And so I think that is a really important asset that you have. I think the Greenprint example that Ted was talking about is another great example of that. So my relationship professionally with Louisville starts around 2012. We were interested in the Urban Climate Lab to understand how rapidly are cities warming across the United States. And so we weren't specifically focused on where are the hottest cities. We just want to know how rapidly they were warming. And so to do that, we compared the weather station at the airport with a weather station that was outside the city in a rural area. And we did this in the 50 largest cities. And we just want to see internally, it's effectively a measure of your heat island. How rapidly is your heat island growing year over year? And Louisville really stands out here. This is not a perfect measure. There's not a tremendous amount of rigor to this exercise. So whether Louisville is warming at a rate that's twice that of Atlanta, I wouldn't put a lot of faith in that. But I think the ordering here tells us something useful. There's something interesting happening in Louisville, in Phoenix, in my city of Atlanta that we need to be aware of. This is mostly important because this kind of warming, the urban heat island, is warming that we can impact. That global scale warming that I started out talking about, we can, of course, over the long term impact through reducing our emissions of greenhouse gases. But one city itself really can't do anything to slow that down. That's a global phenomenon. We can do a lot to slow down what's happening at the urban scale. And so we want to measure what is that rate of warming at the urban scale and how effective might it be to intervene in various ways. And so that's the kind of work we've done. So, I was mentioning the leadership. This did not lead to the most favorable headlines about Louisville in 2012. A lot of it just from the local press. And so, one of the characteristics we found about Louisville when we compared it to other cities was very, very sparse tree canopy, particularly downtown, for a city of this size, east of the Mississippi. And so, plenty of rainfall. And so, what is it about Louisville that makes it particularly hot and humid? We've got a big river, it's a river valley, that makes it challenging. But the tree canopy relative to other large U.S. cities is very sparse. And so there's been a lot of activity in the last 10 to 15 years to focus on this, and we're seeing some positive benefits from that. But initially, just realizing that as a challenge was really, I think, an important observation. And then the other thing just to note, and it's on the leadership issue, Phoenix and Atlanta did not invite me to come give a talk, did not invite us to come do a larger study to figure out how we could work on this problem. And so I think that's really speaks positively about the leadership here, is that it wasn't like, we're going to deny this is a situation. We're going to embrace it and see about how we can lean into this. So we followed that up with a very detailed study, what we call our urban heat management study or heat risk assessment. And we were interested to look neighborhood by neighborhood, block by block to the extent that we could, why the city was warming, and what were the unique trends here that might be related to that warming. So we found that the heat island ranged from 5 to 13 degrees within the county as a whole, which is Jefferson County. That's pretty standard for large U.S. cities. We associated that temperature directly with estimated health outcomes. That was what was most unique about this study and groundbreaking, is that we were looking at not just the temperature block by block. That's pretty novel. Usually we only know the temperature at the airport. So knowing the temperature each neighborhood is something that we don't know when we look at the weather app on our phone. So it's really useful information. Taking that the next step to what are the potential health outcomes is even more important, because it's not just the temperature, it's the baseline health of the population, and it's the adaptive resources. Do you have air conditioning? Is there more air conditioning prevalence in one neighborhood than another? That's a really key variable to how many people are likely to get ill from heat, go to the hospital, in some cases die. So we wanted to focus directly on heat-related mortality. And then if we're going to focus on tree planting as one strategy, we should be able to demonstrate what the cooling benefits might be. Trees, when they're treated as infrastructure, are not inexpensive. I think a lot of people in the room appreciate that. And so when we treat it as infrastructure, we have to put the trees where they will do the most benefit. That's along the streets and in parking lots. That's where we need them. It's the hardest place to put them. We can absolutely put them there, have them be very healthy, have a long lifespan, but we have to treat them as infrastructure, create the planting space for them and maintain them year after year, and then replant them when they do die. And they are subject to damage and storms. So we do this with our stormwater infrastructure. We can do it with trees too. But we have to invest in it and take it very seriously. So we wanted to estimate what those cooling benefits might be to get a sense of the costs. And then we had just a general, we think, if you really wanted to cool the entire county, you'd need about 450,000 trees. It's a big target. And so that's ambitious, but Jefferson County is a big urban county. And so that is not just the city proper, not just downtown. So we've come back most recently to focus on this question again, and we've conducted the same kind of analysis. I'm going to share the results of the analysis with you and show you what this looks like, neighborhood by neighborhood. And we focused on these questions, estimate changes in tree canopy and other land cover features since 2016. We're looking at 2016 and 2024 because those are years in where we have the data we need to see how land cover is changing. We have national data sets that are based on aerial imagery, and we can use that to see how the amount of tree canopy is changing, the amount of paved surface is changing, and then we use that to drive a climate model. Assess the warming trends for the same summer conditions between 2016 and 2024. This is a really important point to make clear. We're looking at hourly weather in 2016 and 2024 based on the same summer. And so we're looking at 2024 weather data from your airport, and we put that in the climate model, but then we vary the land use from 2016 and 2024. We want to see how warming has changed in Louisville between these two periods based on how development has changed, based on how the tree canopy has changed. If we didn't use the same meteorological inputs, then some of that warming would be a product of global scale phenomena, which we can't control. So we're really focused on what is the warming that's directly associated with land use, and then what would be the cooling benefits if we expand our tree canopy. And then we also just focused on what are the stormwater benefits, because heat's a risk for cities, but so is flooding. And so trees are very useful in also reducing stormwater volumes, particularly if they are along streets and in parking lots, particularly if they are appropriately planted with tree boxes that are really stormwater features that are designed to do that for you. So these are 4 basic questions. This is what the land cover mapping looks like. And this is actually pretty unusual data for a city to have. Cities know where their roads are, they know where the buildings are, they usually know where the parking lots are. In your case, you definitely know where the tree canopy is. These other features like grass, barren land, not always clearly mapped. And so if we're going to run a climate model to simulate temperature across the city in the full county, we need to know every square foot, what is this? What am I looking at? And that is how the model ultimately estimates temperature. So this is really useful data for a lot of different applications, and Ted was mentioning this new hub of GIS data. And so this is going to be shared with the community. We have this for 2 years. And so again, you can see across these limited classes how land cover is changed between these 2 periods. So just looking at one of these classes, tree canopy, what we see is, it's not a very long time, but we see some positive trends here. We see that we're actually not seeing a significant reduction in these parts of the more urban part of Louisville. And then most of these neighborhoods are kind of holding steady. They didn't gain or lose more than 25 trees. These are estimates of mature trees that we're looking at. And then some of these other areas over here where we have, in many cases, lots of tree canopy, we're losing some tree canopy. And so we can chart that neighborhood by neighborhood, and that's critical information for you to have. But I imagine if we had done this analysis between 2010 and 2020, we would not see such a stabilized tree canopy here. I think that's a real positive sign for what's happening. It doesn't mean that there are a tremendous number of new trees going in the ground. It means that fewer trees are coming down, and they have time to grow. And as they grow, ultimately that shows up to us as more trees. And so this is a positive trend. Overall, we saw about 2/3 of the neighborhoods are warming between these 2 points, 2016 and 2024. And about 1/3 were basically stable as far as their temperature. Now, the key data project we have here is temperature. And again, that is usually not available to us. When we look at our weather apps, you're looking at the temperature at the airport, unless you're pretty savvy, and then you can choose another airport in the region. And so what we typically don't have is very detailed, what we say is highly resolved, granular temperature data. So what you're looking at here is the temperature on a single day, which was just a hot day in 2024. Again, we're using the 2024 summer for both of these years and then driving the model with the 2016 land use. So on the temperature conditions on August 17th in 2024, which was a hot day in 2024, if Louisville looked like it did in 2016, this is what the temperatures would have been. This is air temperature at this height, and it's for a grid cell. It's a 100-meter grid cell. That's basically one city block downtown. So it's really resolved data. And so we can see, first of all, what's the range of temperatures we see in that kind of late afternoon temperature on one day? Base scenario just means current conditions. We haven't changed the land cover conditions. And we see a range here of about 10 or 11 degrees. So, that's saying in a single neighborhood, you can have a range of about 10 degrees. Are you walking under trees? Are you walking exposed in the sun? And so that's the range of temperatures you're going to see, between single blocks likely in the same neighborhood. That's a really wide range of temperatures to see. And so what that suggests is having more green space, having more tree canopy can substantially cool things down. We know it if we go outside and stand under a tree. It's really a critical resource for us. It's not the only variable. Cool materials, how reflective roofs are, the quality of the asphalt, how much paving you have, all of this is critical. Grass, it all comes in the mix. But trees are the most effective single strategy we know of in Louisville and really anywhere that can support them to cool things down. So this is the first thing we look at, how has temperature changed between these two periods? This is the same day, the same temperature at the airport that we're using to run the model, different land cover. So I can kind of bounce between these periods, and you see gradual change here. It's not dramatic, but it's not that long of a period, but you can definitely pick out that there are areas that are warming up, maybe a few areas that have cooled down a little bit where we put trees. The overall trend is towards warming. And so this gives us, again, really granular data we can use to say, these neighborhoods are where we're seeing the greatest exposure, and these may be the places where we need to focus on our efforts, whether it's tree planting, cooling centers, whatever it is. This is the level of data that very few cities have. It really is an asset to you and really should be useful. Because it is so high resolution, we can kind of zoom in here, and so here we're looking really downtown. This is the Galt House, I think, here. I've got it highlighted more easily to show you here. So the Galt House, looking at the two periods, we saw a little bit of warming. Why did we see warming there? Well, I'd have to drill in the data and go look. I'd have to go look at the land cover data. Maybe they lost a tree. Maybe they've paved over some grassy area. Maybe we saw with the land cover data in 2016 that it was a high drought year. And so we're just not seeing it. So there are all kinds of things that can drive this, particularly when we look at just one block. There's lots of reasons we could see warming or cooling. But when we look at the neighborhood level, we have a lot of confidence that these trends are reliable and they're showing us something useful here. So I'll talk about this as a particular development that I think is useful to think about on the project scale. But generally, we're seeing, across the county, across the city, gradual warming. We expect to see that warming. All of the warming you see here is from land use change. None of this is from the global greenhouse effect because of the way we've designed it. We are warming because of the greenhouse effect. It's just not represented here. Okay, the third question. How much cooling results from expanding tree canopy? Again, this is a critical strategy for us, and so we want to carry out a canopy math that lets you do the work of determining where to put it, how much to invest, and how to do it. And so we can't answer those questions for you, but we can look at a single block here, this is in Louisville, and say, well, where are some of the planting opportunities? And this is a very simplistic way to do this. But what we find is, we have lots of opportunities for planting trees along streets. That's good news. That's where they do the most benefit. It costs more, but they do the most benefit. And ultimately, we need to be focused on cooling things down. And so, certain number of planting spaces here. We want to run a scenario in the climate model again that say, what if we increase the tree canopy? How much would it cool things down? And so our scenario is built around filling half of these planting spaces with trees. So we're not going to put trees everywhere we can put them because it's not realistic. We're just going to say, if you only put trees in half of the spaces where you have room for them now, waving a magic wand on cost, waving a magic wand on whether these neighbors want the trees, those are all the details that I'm going to leave to you and Ted to deal with, right? That's the messiness of this. But we ought to be able to demonstrate, at least with the climate model, would we get significant cooling? Is it worth the investment? Is it worth the engagement to do this? So this is how we built the scenario. So again, we have this greening at 50% scenario. We fill half of these spaces with trees, and we want to know how much that cools down the city. I started out with that graphic showing that Louisville was warming more rapidly than other cities. And I do think this is a distinguishing characteristic. And again, as somebody who travels to lots of cities, neighborhoods with no street trees, it's pretty unusual, again, in a region of the country with plentiful rainfall. And so this is a real liability and a tremendous opportunity to put trees in these spaces. So I'm just showing you some of the neighborhoods when we set this goal. We want to achieve 50% of the trees in the plantable spaces actually already meet the goal. What neighborhoods, if we look at all the planting spaces, already have 50% of those places filled with trees? Bonnie Castle's one. A lot of these neighborhoods around the Highlands, eastern side of the city, already meet this standard. And so in the climate model, we didn't add any trees because they're already meeting that standard. But over here, this is in the California neighborhood, doesn't meet this standard. So in the model, we're adding trees. How much did it cool things down? Okay, so this is back to current conditions in 2024. That was the latest data we had when we did the study. On one hot day, we have temperature for every hour of June, July, and August. I could average it for the summer. I don't present that data to you because nobody experienced that temperature. Nobody experiences a summer average temperature. You experienced this temperature if you were here on August 17th in 2024. You felt this heat at this time in the afternoon, probably 4 o'clock in the afternoon. So these are real temperatures. This is what it looks like current conditions. This is what it looks like if you meet a goal of 50% plantable spaces. That is no joke. We did not gin this up. We validate the model by looking at where we have weather stations. We know the model is very accurate. And so if you were to expand your tree canopy this way, not planting trees everywhere, just half of the spaces where you have room today, you get substantial cooling. And so this is a very positive outcome for you and for all the cities we work with. No cities have reached the potential of tree canopy that's possible. It is infrastructure. It costs money, it takes time. But if we treat it as infrastructure, there is tremendous amount of cooling that's possible. Let's get hyper-local here. And so we get a little nervous when we get too hyper-local because every grid cell is subject to some error here. So I don't want to over-index on how precise this is. But let's just look at where we are right now. So I'm not a total expert here, but I think we are in here in this building. Does that seem right to those who are experts? And so what does it look like simply along a single corridor? If we put trees, this is what the model is doing. The model is planting trees. It gives priority to trees near streets. It doesn't put all the trees along streets, but it gives priority to that. If you were to put trees along the street, is it Breckenridge? Am I saying that right? What would that do just to this corridor? A single corridor. What would it likely do for the maximum afternoon temperatures on a hot day in the summer? 7 degrees. That is major cooling. That is very profound cooling. And so take a single street, take a single corridor. I'd like you to take a larger district of your downtown, wherever it is, and have this experiment. Run it. Invest in putting the trees in. See how much cooling you get in. I believe it will be of this magnitude. What would happen if we put trees in all the plantable spaces? This might sound like a fantasy, but this is what a lot of cities do. Chicago does this. The city of Chicago maintains street trees. They plant the trees. They don't ask you for your permission. They plant the trees. It's in the right of way. It's infrastructure. They maintain the trees. You can't just plant them and walk away. I know some of these lessons are being learned here. You have to actively maintain these trees. And then, of course, some will die, and you have to come replace them. It's real infrastructure. It's like stormwater infrastructure. If we did that, how much cooling would you get? You get even more. You get a lot of cooling here. So I'm not recommending this as your realistic near-term future, but I do want to suggest that this is possible to really focus on having the city manage the street trees, and this infrastructure itself would really move you as far as you need to be to cool things down. Okay, I mentioned before, we want to focus on not just heat, because heat is not the whole story. We want to also focus on health outcomes. And so we use these temperatures we have block by block. We average those across the neighborhoods. And then we're able to estimate using basic mortality calculations. We don't derive these calculations, but there are established response functions that are for all large cities. And so we use somebody else's health response function. And that response function says for every increase of 1 degree temperature, how many more people are likely getting ill, going to the hospital, and potentially dying from heat? On any day, it's very small. It's a very small fraction. If we do that math for the full summer, it's still not a huge number. In this case, it was about 12 people died, we think, around Louisville in the summer of 2024. That number is pretty conservative. When you have a hot year with lots of heat waves, it will be much larger. It's pretty hard to compute that number directly because when people go to the hospital, they likely already had a cardiovascular condition, and the heat stressed their cardiovascular condition. So it's an inexact science, but it gives us a sense from neighborhood to neighborhood where there's the greatest heat risk, which is a product of temperature and baseline health. What's the health of the population, and what are the adaptive resources? Do you have air conditioning? Can you go to a cooling center? These are all critical variables. So we really think this is more useful than just temperature alone to think about where your most vulnerable neighborhoods are and how to intervene. So we hope you'll use this information as well. Okay, so I obviously think that managing heat and heat risk is a really important thing. I think we're getting close to some pretty critical thresholds in really all of our cities, and we need to be investing in this now and taking it very seriously now. But I do not think climate adaptation is the singular or the most important goal for your city. I think we have learned, certainly over the period of time that I've been doing this, if we think about adaptation as a standalone goal, we're not likely to succeed because there are greater needs in the community. And often, climate change, climate adaptation, they're rather abstract concepts to most of us anyway. So I know Mayor Greenberg, who I had the honor to meet with yesterday, has prioritized affordable housing in Louisville. And so I think about how can these two goals be integrated? Is there an overlap here between having more green spaces in cities and affordable housing? And so I think there is. And so I wanted to just think about kind of two of what I know are really important municipal goals right now and how they align with these kind of adaptive investments if Louisville is to make them on a larger scale. Let's think about affordable housing. It's of course not just the equation of the rent. The rent here is the largest piece of the pie, but this is for low-income renters across the country. 46% of monthly income goes towards rent. That's a really big fraction. All right, that's very difficult to do. But then when you add in utilities, it's another 15%, and then add in transportation. If you are auto dependent, if you must drive a car, which is the case for many, many people who are renting and even in affordable housing, it turns out these numbers are very similar. So again, these are national averages, not Louisville, but about 46% on both, on the rent and the other aspects of housing costs that are associated with the housing itself. Where is it? Do I have options for transit? What are utilities? What's the temperature outside? How much electricity am I using? How much natural gas am I using? These are big components to consider when we think about affordable housing. And so this is a recent kind of redevelopment in Louisville that I'm sure many of you are familiar with in Beecher Terrace. And so this is a project that's been focused on affordability in a compelling way. But you can note here in the photo, at least in this section of the development, no trees. And so this is going to create a situation where there's likely a greater heat burden, likely greater expenses on utilities. Can we get a sense using the data that I'm sharing with you what that heat burden looks like? Well, we can do our time travel. I'm picking this project just because it was redeveloped within this narrow window. There are lots of projects we could look at. 2016, this is classic, courtyard housing from the 1930s. Many, many cities had that. My city actually was the first to have this. Courtyard public housing is the way we referred to it at that time. And what's important here is the courtyard itself. There's a lot of green space here. Sorry, I'm losing my pointer here, but these central courtyards were a key part of the design. It actually is a legacy of Central Park in New York. There was a belief that having this green space between the housing units would lead to more community interaction and lead to more eyes on the street and would just have positive kind of social benefits for the community. And so it was a fundamental component. But then you also, of course, after so many years, have these mature trees that are part of the community. They weren't planted as mature trees, but they were planted and have come in and they provide critical cooling. The redeveloped community at Beecher Terrace as part of the development process, which makes perfect sense, particularly for an affordable development where housing costs, construction costs are key, trees were removed. This is the common cycle. The challenge here is that the courtyards are largely replaced by parking lots. And so, we're really not going to bring trees in here. We could, but it'll be more expensive. And then in some cases, there are a few trees along the streets, in some cases not. What has this done to temperature between these two periods? We can see in some of these blocks a really dramatic increase in late afternoon temperatures on a summer afternoon. And so in this case, 8 degrees. That is going to create an additional heat burden. There are probably many amenities here that are laudable about this development. I am not critiquing the development and not critiquing really valuable affordable housing initiatives. But it's the same case in Atlanta, really in DC. We're not necessarily thinking about the full equation, particularly on the utility side. It's not the largest piece of the pie, but it's a piece of the pie. So could we do this differently? Could it still be affordable? If we look at the basic lane cover, and again, this is what the data enables us to do now, we can see, clearly what happened. It's like the trees are gone, the grass is gone, with the buildings, I don't know if there's a larger building footprint, but certainly the parking lots have rendered this a hotter environment. And so, this is somewhat unique to have the need for so much parking right on the edge of downtown. And so is there another way to satisfy the transportation demand of this community? It's challenging. Can it be done immediately today? Maybe not. But we can envision a world where we could have less parking, and I think this is a key, whether you're living in affordable housing or any housing in Louisville, we could have less parking downtown and in lots of places, and less street parking. It's critical land that we could use to cool things down in this case, but we shouldn't be naive about it. So I'm going to come back to what the transportation alternatives might be. This is an example of what we call climate resilient affordable housing. It's also highly affordable. All the units are affordable, like in Beecher Terrace. But there's been a real effort to make this very energy efficient. So this is known as passive house construction. The energy demand here per unit is at least half of what it is in other market rate units of this design. And so the energy demand is much, much lower. You have cool roofing, you have green elements throughout. Of course, it's multifamily, that helps. You have solar panels, there are reduced stormwater management fees. All of this is designed for not just affordability in terms of the developer and the monthly rent, but the utility costs. And then of course, this is sited in proximity to good transit. And so you don't need the parking. And so you've just, that 30% transportation burden is greatly reduced if you can manage to live in this kind of a complex without a car. It's not, that's not easy and really in any environment, but it can really increase affordability, and that's a major goal we should be focused on. Okay, Louisville transportation. This is not a picture from Louisville, but autonomous vehicles. What is the future of autonomous vehicles in Louisville? I have no idea. I haven't seen them driving around while I've been here the last 48 hours. We do have them in Atlanta, and they are everywhere. And so it doesn't warm my heart to see autonomous vehicles everywhere unless I think about one thing, and that's maybe we don't need all this parking. And so this isn't like next year, but it may be in the next 5 years or maybe in the next 10 years that our cities have many, many, many autonomous vehicles. I can tell you they're rolling out very rapidly in my city, and there are plans to introduce these across the country. In addition to kind of the private Waymo style vehicle that's out there, there are plans in the works. It's happening now. It's happening in Atlanta. We have shuttles that look like this for the World Cup that are autonomous, that are moving in specific zones, having more demand dispatched, small scale public transit that you order on demand on your smartphone that will take you where you need to go and pick up other people is definitely part of our future. And it will be much more affordable. So again, it's not here today, but I'm not talking about 25 years from now. I'm talking about 5 to 10 years from now. Could be a very powerful model, particularly if it's focused on the downtown district for affordable renters, but for everybody, and enables us to greatly reduce the amount of parking that we need. That provides space for more affordable housing, floodable spaces, trees, outdoor amphitheaters. What are the amenities you want in your downtown? What makes Louisville have a quality of life that you want? You're going to need space for that. It's the critical variable. And I think we will find it from parking in one degree or another. Okay, one other example that is on the mayor's list, it's economic development, and that's the critical goal for any mayor. And so, I highlight this in two respects. One, to talk about adaptive urbanism with another example, but also, I think the mayor chose a great spot here under a tree. This is a lovely spot to have, a public announcement. But then we also look here, no trees. This is pretty unusual for large U.S. cities to have blocks and blocks downtown, not one tree. Like, it's not every block, but it would be hard to find that in many cities. And so, I'm not in any way picking on Louisville. I'm highlighting the opportunities. And so, are trees relevant to economic development? The literature suggests that they are very relevant to economic development. This is looking down at your convention center. And so, just showing you, what's the in just this set of blocks that you see, what's the composition of materials? Road, roof, parking, tree canopy, grass. So we can see it's the impervious materials. You can see it in the image. You can see it when we do it quantitatively. Tree canopy at 2%. That's really low. It's way too low for a district that's got your convention center. It's way too low. And so this is creating a hot environment that's down there. It's an opportunity to cool things off. Can we do this in a high density environment? Absolutely. Manhattan, 21% tree canopy. 21% in the densest city in the United States. Can we do this in Chicago? In just the Loop area, 17%. Okay, so your downtown's not at 2%, but I think it may be at like 4 or 5%. It's low. And so you can do this. You have to invest. You have to create the plantable spaces that are healthy for the trees, and that's an infrastructure project. It's, as Ted's been saying in the last 24 hours, it's not the cost of the tree. It's what the tree is going in. It's the infrastructure. That's the cost, and the maintenance and the commitment to that. Again, Chicago and New York maintain the street trees, and so it's a big part of the municipal budget. It's nowhere near what they spend on stormwater and issues of that nature, but it's fixed in the municipal budget, and it enables them to maintain the tree canopy. But it is not just there to cool things down. I think we would agree. It makes the environment lovely in many ways that people desire. And so it's a real amenity that shows up in economic data. So what do we know nationally from street trees? 2 to 4 times more cooling than reflective materials or green roofs. Reflective materials are great, cool roofs are great, but trees are the most effective thing we have. And so we know they provide the cooling. They do it right where the pedestrians are. Consumer expenditures, retail, 9 to 12% greater with street trees based on a number of surveys in a number of cities. The perceived design quality, I think trees are beautiful, but I'm not the only one. When you're in a district with street trees and we survey you, you perceive it to have better design. You favor that district over other districts. I think we all know that to be true unless you just don't like trees. Trees increase property values 3 to 15%. A single tree in your front yard, a single mature tree in your front yard of your home can increase the property values by 2 to 3%. That's real money, right? I mean, that is clearly something that the market values. Trees reduce stormwater management by 20 to 35%. And again, stormwater burden economically on cities is huge. We had flash flooding yesterday. Did anybody experience flash flooding? It was intense. And that is, in all cities, are getting overwhelmed because our infrastructure is not designed for the intensity of rain that we're getting. Having regular street trees can diminish that burden so you don't have to invest so much in your stormwater infrastructure. And then overall, what's the return on investment? For every dollar invested in street trees, 2 to 5 times returned. Basically in property values, stormwater cost savings, and greater retail and tax returns if you're thinking about just the municipal budget. Trees pay for themselves for sure, but they're not free. They're not cheap, and so it has to be done correctly. I mentioned stormwater as far as our data. We ran these numbers for you as well. We're not planting trees. We're not designing our tree scenario to maximize the reduction in stormwater runoff, but we know we have benefits, and this is what the models show. And you can just see, neighborhood by neighborhood, a reduction here that ends up being, around 20% maybe in runoff from a pretty intense storm, a 25-year storm that we run in the model. Okay, so adaptive urbanism as an idea is just simply this idea of leveraging climate adaptive actions to advance non-adaptive goals. It means we don't need to lead with it. It's important enough to lead with, but there's no reason we should do this at the expense of affordable housing or whatever it is, economic development that the city values. They go hand in hand, particularly if we design them that way. And so I think that there's a great opportunity here, again, given the space, to think about adaptive strategies that advance other strategies the city has, other goals. Just two final quick examples and I'll wrap up. Streeteries in New York. This is a pandemic innovation. I don't know if you had any in Louisville. But many large cities moved outdoors, needed more space for gathering, needed more space for retail, and so basically displaced the on-street parking. On-street parking in Manhattan is valuable and beloved. And so that's not a small decision that's made, but you can get around New York without a car, you can get around Manhattan without a car. It's a lot easier to do it that way if you do it that way. And so, you know, this is an adaptation that was not carried out for climate change, but it has climate benefits. And so we have a lot more greenery. We have physical shade structures. That's another way to cool things down. And then we have more trees because there's more space for planting trees. These trees were already there. And so New York today has maintained these streeteries. There are 50 linear miles of streeteries in New York that is displaced on-street parking. This is a great example of what I call adaptive urbanism. This is not a goal that was set to advance climate management, but does it very well. Second example. There are many cities that are doing this, that they are largely citing increased bike infrastructure, pedestrian infrastructure, and what we call bioswales here, which are planting spaces, but they're planting spaces engineered to collect and infiltrate a lot of stormwater. So this is basically a stormwater device. It's also a great planting space for trees. We should do this for the amenities, for the environment that particularly young people want. They report not wanting to be in a car. They report wanting to have other modal options to get around. A lot of us in this room probably would like this too. And so significant biking infrastructure combined with bioswales and trees is a wonderful example of adaptive urbanism. It's something that we should do because it improves the quality of life in our downtowns. It's also a really amazingly effective strategy to reduce flood risk and to reduce temperatures. So back to Louisville. My concluding idea here is that if you want to create a city that is both economically resilient and environmentally resilient, I think you've already done the hard work, the hardest part. And that is saving these kinds of spaces that are scaled to humans, that are endlessly adaptive to all kinds of different uses over time, and that are just inspiring to the people who move through them and live in them. I'm from Atlanta. We don't have a single block with these kinds of architectural riches, not one. This is a tremendous asset to you. The other kind of embellishments that are needed, street trees, pedestrian, biking infrastructure, whatever you want, bioswales, solar PV on the roofs. These are just the rather simple additions to these standing monuments you already have. And so I think that is the easier part of the equation. It's not easy, but you really do have some amazing assets here to work with that would make this a very attractive place for lots of people to come. And I think that people will come. And so I envy the potential you have as a city. I wish we had these kinds of landscapes in my own city. And so wish you well with your journey. Thank you for having me today. Thanks so much.